The broadcast is now starting. All attendees are in listen-only mode.
Hi everyone, can you hear me? Please use the chat window to answer. Great. Alright, so let's start off. Welcome to this webinar held by Sandeep Giri and organized by CloudxLab on big data processing using Apache Spark and Hadoop distributed file system. So this is the first of our hands-on series with more to come. My name is Anjana and I'm part of the CloudxLab team here. I'll quickly take you through what to expect of this webinar today. So there's going to be a 2-hour session with a 5-minute break halfway. Since this is a demo session, we have a lot of attendees, which is why everyone is muted. So the chat window that you see on the tool, or the GoToWebinar tool, will be your primary mode of communication with Sandeep today. You can ask your questions by typing them in this window. Only Sandeep can see your questions and he will be reading it out for everyone's benefit before answering. You can help Sandeep respond to more queries by keeping your messages short and avoiding chat language. That would really be helpful. He will be answering questions at the end of every slide, and he's someone who encourages questioning, so please keep those questions coming. Those making notes can sit back and relax. We will share this presentation and the recording with everyone present here. I will hand it over to Sandeep from here. In the meantime, please send us a one-liner with your introduction so we get to know you better as well. Have a great webinar all.
Hi everyone, are you able to hear me clearly? And can you see my screen? Alright, so everybody is muted except for me. So everybody, you'll have to ask your questions using the questions window. Great, great. Looks like everybody is able to hear and see the screen clearly. Feel free to ask as many questions as that comes to your mind. All right. So I'll try my best to answer the questions. All right. So great. All right. All right. Great. Let's jump in. So in today's agenda, we have the following. First, we will understand what exactly is Apache Spark, and then we will give you a brief introduction of CloudxLab, and then we will. So in this session, as we go forward step by step, we will do the hands-on. It's not like first theory then hands-on. It's like one slide theory, other slide practical. So that's how we are going to do in the real time. All right? Okay. So first we are going to go through the RDD, what is the RDD, and then various transformations, actions, and then we will go through the further demos. All right? The overall objective of today's session is compute the word frequency as in how many unique words and what are the, how many times each of the unique word has occurred in a text file which is stored in HDFS and by the help of Apache Spark. All right, that is the core objective of this one. Yes, the screen recording as well as these slides will be shared with everyone. Do not worry, but if you want to take a screen recording or if you want to do the screenshots, please go ahead from this session, as well as you can take the notes. All right, so feel free to whether you want to do the screen recording or do anything, but do not worry, we will be sending you the recording as well as the slides, so stay focused on the session. All right, let me also record, although there is one more person recording the session. Yes, I have started recording, Rohit. All right. All right. I'll explain what is CloudxLab soon. Don't worry. So the objective is basically the most simple question, which is how would you do the word count? Word count means finding the frequency of all the unique words present in a big text file. That's the overall objective of today's session. And with this objective in the mind, we are going to go through all the concepts that are required in order to reach there. Okay? The debate whether this is the right way of doing the word count or not the right way to do the word count, that's, we're keeping it separate. If you have been attending my introductory sessions on Hadoop, you would be clear by now that where your single node computer fails to do the processing, we move to a cluster like Hadoop or Spark. And then using many computers, we solve the problem. So this objective here, if you reread it, it means we have to compute the word frequency in a big text file which is available on Hadoop, which means it is distributed. This file is broken down into blocks and is on the whole cluster. And we are using Spark, meaning we are going to use many computers parallelly in order to solve these problems. Okay, let's move on. A quick introduction to CloudxLab session. What does it mean by CloudxLab? So basically, when I was training on Big Data and Spark as part of No Big Data, so we realized that most of the students were not able to do the hands-on because of installation issues. Therefore, what we did was we set up a cluster. We set up a cluster for all our students so that they get to learn through practice in a real environment, and they can connect from anywhere and any device, and they get a centralized data access without any installation. There are no issues of compatibilities while installation, and we can provide a better support. So this is what a CloudxLab means. CloudxLab is nothing but a Hortonworks cluster along with all the components from Cloudera set up in order to practice any point of time in the day. Okay, so it's always available to all the students. So this is what a CloudxLab is. All right, so it's basically best of both worlds. There is, on one hand you have Hortonworks, other side you have Cloudera. We have taken the best components out of the two and installed it so that our students don't have to install it anywhere, and they can just log in and start using. Okay, so you can just, if you want to have a look, so for me, because I've already enrolled, so let me just sign out. So I can if I'm not enrolled already, I can just click on enroll now and then go through payment, and then once I'm done, I can log in with my Google ID. Okay, so I'm logged in with my Google ID. Now you can see I'm logged in. This is my login and password for Hadoop, and I can start using Hadoop either by Ambari, Hue, or Console. These are the three interfaces. Ambari provided by Hortonworks, Hue provided by Cloudera, and Web Console is something which we have done so that you can see the terminal, you can connect to the servers without having to install anything. So Web Console is like a full control command line. You can do anything here after logging in. Okay, so here we go. So this is what a console looks like. Here it's a proper Unix console. You can run Python, you can run R, and you can run everything you want. Okay. So this is the full console. You can see that I'm using the pwd ls-l. These commands are Unix commands. Okay. So this is coming from CloudxLab. I'm logged into one of the computers called e.cloudxlab, and this console is at CloudxLab. So anything you run here is going to run inside CloudxLab, and this is what we have done from the browser. All right. So this is a brief about what CloudxLab is. A question from Ravidas is, but this is distributed mode of cluster, right? It's not pseudo random mode. No, it's a distributed mode of cluster. That's right. That's a very good question, Ravidas. Thank you. A question from Hemant is, so our access will be private, means this is not shared. Our data set will not be distributed, disturbed. No. Your home directory is your home directory. This is my home directory. This is my data set. Unless I say chmod and I give permission to my home directory, nobody can access it. I have given the read-only permission to my home directory so that I can coordinate with all my students quickly. Okay? And also, I'll just open Hue as well. Hue is a web browser-based, nice-looking user interface. All right. So I'll just open this. So you can see that this is the HDFS. So these are my files inside file system, and the common data sets which are shared with the students is available here. So we have done that way so that we can put data sets at a common place. Everybody can access those data sets while doing the exercises. Sarveshwara's question is how it is different from AWS. Good question, Sarveshwara. So at AWS, we have to set up everything by ourselves. Okay, and it costs a lot to spin off your real cluster. Okay, here it's hosted on, right now we have 5 nodes, but when load increases, we increase it to more nodes. Here, using 5 nodes, you will be doing the computation, and if you run your own AWS cluster, you will have to first install it, and then you will have to pay for that. Okay, here the prices are very, very small. Okay. Next question is, what's the cluster size in CloudxLab? Right now we have 5 for today. We will keep on increasing as the load increases. Rohit's question is, can we start learning through Scala? Yes, Scala is available on cloud, but for today's session, we are going to go through Python because I found more people know Python than Scala. So it's better to learn with Python, and you can do everything with Python what you can do with Scala or Java. Piyush's question is, can I use CloudxLab to host apps in production? No. The answer is no, because we do not take any kind of guarantee for your production environment. Okay. So do not use CloudxLab to host your production apps. Hemant's question is, do you have NiFi Hortonworks tool in the cluster? Yes, we do have. A question from Vijay, do we have the replication of file stored in nodes? Yes, of course. Rajit's question is, what is per node question? I mean the machine config. So it is actually different kind of machines. For name node, we have really high-end machine. And for data nodes, we have smaller machines. Okay. Question from Ravidas. Thank you for that question, Ravidas. Do we have Spark R support in the cluster? Yes, we do. So everything that's required for Spark R has also been installed. For example, Spark R requires R libraries as well as R. Those things are available as part of the cluster. Next question from Venkata is difference between Hadoop and Spark. So Spark is nothing but it tries to do the things faster using memory rather than every time writing back to the disk. That's the slight difference between Hadoop and Spark. The objective of Hadoop and Spark were two different. One was designed in a batch-wise fashion, while Spark was designed to get things done immediately. All right? All right. Yes, Senthil, you can jump to Spark instead of MapReduce. No. So I would strongly recommend everybody to learn Hadoop MapReduce as well as Spark MapReduce. Okay. But today's session we are going to focus on Spark MapReduce. Srihari's question is, what is the data size limitation we can use? So the data size that we can provide can be higher, but each individual can upload up to 2 GB of data. But if you have a special requirement, you can drop us an email at reachus@CloudxLab. We can make sure that your data set is available. Okay? Ramakrishna's question is, that's a good question. Can we do centralized dataset analytics as well as distributed dataset analytics using CloudxLab? Yes, you can do. So the way we do is, we put the data centralized on HDFS. Now, when the data is centralized on HDFS, all the users, everybody can access the data from the same place, although internally the data is distributed. For humans, the data looks centralized while the data is actually distributed. A question from Ravidas. Can you just tell me the difference between R and Spark R? If a model is developed in R, can be run in Spark R with just data frames created? So that's a very tough question, Ravidas, and I would require more time for this. Can I take it offline? Okay, just drop it over reachus at CloudxLab. I'll try to answer it there. Okay. Wow, there are a few more questions before I move. All right. Okay. Senthil's question is, how can I visualize the data stored in HDFS? Do we have any visualization tools in CloudxLab? So as part of Hortonworks and Cloudera ecosystem, the visualization are mostly provided as part of the as part of Hive. Okay, so you can use Hive visualization in this, but if you want to put more visualization, you can run R, and you can move the X window to your desktop, in order to visualize the data. Okay. Ramakrishna is saying, give real-time examples, please, for centralized and distributed data set. So I'll again, Ramakrishna, could you drop an email to reachus at CloudxLab, because that's actually going a little bit beyond the plan in the class. All right. A question from Pratibha. It's a question from Prabha Anjana. Is RStudio available in CloudxLab? The quick answer is no. We have only R without much of a visualization. Visualization you can do. There is a way to do the visualization, but it's a basic R which is available. A question from Gopal is, can we replace Hive in Hadoop with Spark? There is a separate thing called Spark SQL. You can use that instead if you are inclined to use Spark. Next question from Kritika is, what we should prefer if we are starting learning big data as a fresher, Java, R, Scala, or Python? So if you have no idea about any other language, I would strongly recommend Python first, and the rest will follow. Okay? So so if you are inclined only to go into analytics, only analytics, not into the big data and analytics, then R is good enough. But if you are planning to go for big data analytics or big data, Python I would recommend would be a good idea. A quick question from Ravi is, if there are Hive tables in HDFS, are these tables distributed or it is single table? Ravidas again, it's going to be difficult to answer all the questions. So could you please send an email? I'll try to answer it over the email, because yeah, it's a little big question to answer. Ramakrishna's question is it possible to do real-time analytics in CloudxLab? Yes, and we will show you how to do it using Kafka in the second session of this series. Okay, so you have to stay tuned. So we will be using Spark streaming with Kafka in the second session. Okay, so Gopal Krishna's question is, we have already implemented a Hive project in production. Is it possible to replace it with Spark for performance? And okay. So it's not directly, you cannot replace with Spark SQL directly, but I think Hive people are working on making it work with Spark. So you can check there. A question from Arun is, do you provide ID support in CloudxLab? Not really, because it's a backend, it's a server-side cluster, and server-side clusters do not generally have any IDs installed. And okay. Question from Ramakrishna, thank you for the question again. Can we implement machine learning algorithm? Yes, we do. We did an inception on our CloudxLab recently. So you can, yes, use machine learning as well as deep learning on the cloud. Okay. Akash is saying, how is it different from big data? It's not different from big data. Big data is, big data means a big, very big data. And these are the solutions to big data, whether Hadoop or Spark. So, all right. A question from Hemant is, there is a session from Cloudera to run Hive on Spark on May 3rd. Thank you, Hemant. I think that helps answer a question, and I also got updated because I knew that they were working on making Hive run on Spark, but I didn't know that they have already done. Good. Thank you, Hemant. A question from Rohit. Just one question. Why can't we start with Scala or Java? Because I heard Scala is growing up in big data. Okay. So we will be, yeah. So the reason is that Scala is, yeah. So that's a choice which we have made for this session. If you are inclined for learning in Scala, you can go ahead. The philosophy, the theory, the concepts, and almost every command will remain similar even in Scala. So that won't be too much of an expenditure. Yes, I'll be sharing this video, that's it. Yeah, that's right, Ravidas. We can use Hive context, but the problem is with Hive context, as you correctly put it, that Hive context actually just accesses Hive, and most of the computation is delegated to Hive. Okay, that's a context. The context here in the question which I'm trying to answer is, can I transport? So it'll better if I take the question outside the context. Okay. So how to run a Hive query on Spark rather than Hadoop? That's a big question to answer. So I can answer it over the email separately, reach us at CloudxLab. All right. Thank you, Rachit. I'm happy that you're finding my answers good. All right. Cloudera Hadoop does not come with support of Hive context with the Spark, hence does not work. Thank you, Ravidas. Thank you for this answer. So a better thing would be I'll arrange for a discussion and then we can have a Hive and Spark. So yeah, Rohit, which question are we referring? Okay. A very good question from Parvela Malikram. We can import data from DB2 to Apache Spark and vice versa. Is this correct? Yes, we can do. The wonderful thing what Spark guys have done is done the integration really well, as you will see further. Okay. Rohit's question is, why can't we start with big data? Okay. Actually, just a second, let me read the full question. Why can't we start with Scala and Grin? Okay, so yeah, so that's a choice which I am taking for this, because what I found is the code which is there in Python is far more easier. It's not too intimidating for a newcomer. That's why I have taken Python as a choice. All right. So it's a conscious decision even in the class. So the main objective of most of the technology or most of the technology education is get the adoption of the technology correctly. Therefore, I'm trying not to use Java or Scala. And this is great for learning learning fast and quick and in a right way. Therefore, I'm going ahead with Python. But once you are done with Python and you are inclined a little bit for Scala, it won't take you much time to move to Scala quickly. Okay? All right. Yes, Rachit. So the Python is very much, very much similar in the syntax. Okay. So you won't have much of a problem if you are from Java background. Parvela's question is MapReduce used in Apache Spark as well? Yes. Thank you, Parvela, for the question. Yes, it is. And you will see it very soon. Okay, Rahul's question is, Rahul, I'll answer your question after like 2 slides. Okay, Till then, I'll park your question here. Okay, I'll park your question here, and let me save the notes as well. We will call it. We will call it Spark. Okay, so great. A quick question from Abhilas. Can we use Java for implementing Spark? I mean, if you want to develop with Spark, yes, definitely you can work with Java, Python, and Scala, and even R. So nothing to worry. All right, let's jump in. So that was the objective. So we talked about objective, and then we talked about CloudxLab. All right, a little bit about me. I'll be very quick in this. So I did my graduation from IT Roorkee in 2002, and then joined a company called DE Shaw. We built big data systems before the term was coined. We had a 10,000 node cluster in 2002, and we work on the kind of data for which transferring it over the internet was tough. So our data used to come from New York over the flight. So flight was faster than the electron. And afterwards, I built a company called TBits Global, where we built an enterprise-grade document management system, which is being used in power plants as of today. And then I joined a company called InMobi and Amazon, where I worked mostly on distributed computing and on churning huge data. And afterwards, in 2014, I realized that there is a need of big data learnings. Therefore, we started Know Big Data. And then for our own students, we set it up a cluster, and then we made it a separate company altogether. So CloudxLab is now a separate entity, which caters to many companies, many students parallelly. There are more than 5,000 students using CloudxLab as of today. All right. So this is about me. I'm Sandeep Giri again, and so today we are going to talk about Apache Spark. So what exactly is Apache Spark? It's basically a fast and general engine for processing large-scale data. Okay, for processing large-scale data, it's basically a cousin of MapReduce. It's a really fast version of Hadoop's MapReduce. The way it does things faster is, instead of reading, writing all the time from the disk, it does it in the memory. And it's built on the similar paradigm as map and reduce what is there in Hadoop. Alright? So that doesn't mean, if you haven't read about MapReduce in Hadoop, that doesn't mean that you should not attend this session further. Okay? I'll try my best to explain things even to the people who have not worked on Hadoop yet. Alright? It's well integrated with almost every cloud-based ecosystem available. So that's about Spark. Spark is really faster version of MapReduce and is well integrated with Hadoop and is similar in nature with MapReduce. Alright, so that's a very quick introduction, and this diagram will make things very easier for you. Alright? Okay. So let me take a step back. So what we told just now about Spark is it does the computation, meaning you give it the program and you tell Spark how to run it, whether and whether to bring data from somewhere and to do certain computation, whether to clean data, whether to do the text processing, whether to do. So whatever you write a program. Okay, you write a program or you write instructions and give it to Spark, and Spark will run it over the whole cluster. Okay, and that cluster could be a Hadoop yarn cluster. That cluster could be Amazon EC2 cluster, or it could be a standalone cluster which you have set up for only Spark. Spark comes up with its own kind of a cluster manager, and then you can use that. Or if you have something called Apache resource, you can run Spark everywhere. Okay, so Spark is a way of distributing your work on many computers. When I say work, work means computation. Work does not mean that we are trying to distribute the storage. Okay, so so Spark can run on any of these platforms, or you can see cluster managers. Cluster managers are somebody who take care of the machines. Like Hadoop Yarn cluster takes care of which machines are up, down, and which machines are free, which machines are busy, and how to add a new machine to the cluster, and so on. So Spark can tell Hadoop Yarn that, hey, get my work done on these 10 machines, and Yarn will do that. Same is with Mesos and EC2. So Spark core is the one which does the main job. Spark core is the one which does the main job. Now, on the top of Spark core, you have libraries, and then the way you interact with these libraries is by the way of language. You can talk in Java. You can talk to these libraries of Spark in Python, Scala, or R, or SQL. So that's the wonderful thing. So you as a user can talk to Spark using any of these languages, and then you can use all kinds of libraries, libraries for graph processing, libraries for machine learning, libraries for streaming, and whatnot. So all of these libraries are available as part of Spark. Now, question is, can you read data from X database, Y database, X file system, Y file system? Yes. Spark has been designed the way that it should talk to almost all databases. And on top of it, it tries to run your logic near the data if possible. Whether the data is in HDFS, HBase, Hive, Tachyon, it can talk to almost any kind of file system or databases for you. It can even talk to Cassandra and tries to execute your logic on the machine which are near to Cassandra. So you can see that in Spark, it's a core computation engine. It does not provide storage. It depends on some third party to store. A quick question from Srihari. What is streaming? Streaming is processing data as it comes. And that's exactly the word. Processing data as it comes is what defines streaming. Sadanand's question is, can save and access Spark process data into any in-memory based column store or Apache Arrow? And yes, it can do most of that. And question further is, please explain how we can do it in CloudxLab. So any documentation you follow, okay, on working on Hadoop or anything, the same thing will be valid for CloudxLab, because CloudxLab is nothing but a hosted cluster from us for our students or you. Okay, so anything can be done there. All right, does that answer your question, Sadananjan? Sadanjan? I'm sorry, I'm standing a little bit far, so it's okay. A question from Srihari is, you said Spark does processing in memory. Spark takes PB data of memory? Not really. So that's a clever thing. That's a very good question. Thank you, Srihari. So here, yes, I said that Spark utilizes RAM in order to solve your problem. But if the RAM is not available, it can put it in the disk. It can put it in all kinds of ways it utilizes. Okay. So if you have terabytes of data, it doesn't mean you need terabytes of memory in the computers. Not, okay? All right. Is my voice clearer now? All right, all right. So now let me answer a few more questions and then we move to the next one and we start doing something instead of only talking. Okay, so now we move, okay, next question is, can I interpret that MapReduce is Hadoop architecture, in Hadoop architecture is replaced by Spark Core? That's good, yes, Senthil, that's exactly what it is. It's a big, on the little political answer, I'll say that it's a debate question that whether it will replace MapReduce or not, but the ecosystem wise, yes, MapReduce is replaced by Spark Core. A question from Gomati is, what is GraphX? GraphX is a library which helps you convert your graph problems. What is graph problems? Like you have to do the processing of Facebook friends. Friends of a friends of a friend. If you take the graph, it's a billions of users. Right? Therefore, to do that kind of graph processing, you need a bigger architecture, ecosystem of many computers, and that's what GraphX is. GraphX is a library which can convert your problems into Spark, your graph problems onto Spark Core. Next question from Ravidas is, are Spark jobs same as MapReduce? If no, what would be the difference? You will notice that now, all right, as I go ahead, because explaining this part is actually tough. Explaining this part is actually tough. So so the easiest, right now, you can think of the way you interact with the Spark is the way you interact with pig, okay? The pig from this thing. So I'll explain to you the way of interaction and then things will be clearer to you, all right? Parvela is saying, what is used by Spark while doing an import? So we do not generally import data from external sources to Spark. Instead, we load directly from the remote sources into Spark. Anything, whether XML or JSON, both can be used. Good question. Next is, Vijay's question is processing done on data nodes? Yes. The data locality, when Spark runs anything in the cluster on Hadoop and is trying to process the data in HDFS, it basically runs it on near the data. It runs on the same machines which are running the data node, holding the same data which is trying to process. So the computation is moved closer to the data. Srihari's question is, how Hive, HBase and HDFS differ in file storage? Hive HBase is a file system, is a database, while HDFS is a file system. So that's a separate debate altogether. We can have a separate discussion for that. And okay, so all right, that's a good question, Vijay, regarding the data locality. All right. Santhil's question is, does MapReduce support Python, Scala, or only Spark does? So MapReduce supports Python and Scala and any language by the way of MapReduce streaming. Next question from Rachit is, can you please elaborate on MLlib and Apache Mesos? Mesos is similar to Yarn in the sense that Mesos manages your cluster. You can create the full cluster using Mesos. And MLlib is a machine learning library which comes bundled with a lot of algorithms of machine learning similar to Mahout. MLlib is far more newer than Mahout. Venkat's question is Spark Core is used for what? So Spark Core is your alternative for the MapReduce, as simple as that. MapReduce of Hadoop. Yes, Srihari, graphics library is only for problem solving online networking sites, not only online networking site, but graph related problem. It could be something like you want to you have a lot of data where there are relations, complex relations between one object and another object. Those kind of complex and big graph related problems can be solved using GraphX. Okay, serialization process available in Spark. Yes, it is done very well. Next question from Gomati, what are the input sources of Spark streaming from JMS or anything, something? So interesting part about Spark streaming is it can take the data from anywhere, where almost like hundreds of sources. Okay, there are many connectors are available. Question from Sarveshwara is, in fully distributed mode, where we will install Spark. So Spark is not installed on Hadoop Yarn. You just download the library of Spark on the node from where you are launching your work. Yarn will take care of installation every time you run it. And that's the beauty of Yarn. On a Hadoop cluster, you don't need to install Spark on every node. You just download it on the node from which you're launching and you're good. Where will the data be stored after processing? Anywhere in these. It's up to you where you want to store. Okay? Whether you want to store on HDFS, HBase, Hive, Tachyon, or Cassandra, you can store on many data stores. Ramakrishna's question is, in CloudxLab, Spark has been installed in the cloud? Yes. Good. Very great set of questions. Time to move on. All right. Again, Ravidas's question is, what's the difference between master node and an as name node? We can answer this as part of our Yarn discussion. Can you leave it with reachus at CloudxLab? We can take a further, because it's a very deep question. All right. Good. Great. I'm sure today we have great set of audience in this class, and there are actually 64 audience right now, 64 individuals with a great set of background, and we are going to go ahead with the further hands-on exercise. All right. Now that was a brief discussion on the Spark architecture. I'll not get into more theory. Instead, we will like to do something. So first is starting with PySpark, or how to launch our first hello. Okay, so there are two ways. First way is you log in into the console on CloudxLab. If you're taking the membership, you can just go there and then say login and then click on the console. The other way is you can download Spark from here and install Python on your machine, and optionally install Hadoop, and then run both of them integrated. Okay, and so this is a little bigger one. You will have to download, and it'll take some time, and then install Python and then run it. All right, we will go ahead with the CloudxLab way, whereby you can essentially go here and enroll, go to pricing tab and enroll, and then you will see something like this. It is basically my login password for my Hadoop cluster. Okay, now we are going to use, first I'm going to show which data I'm going to churn. Let me open Hue. Hue is essentially a way to interact with Hadoop. So since we have to process data stored in Hadoop, let's take a look at this data file inside HDFS, which is Hadoop Distributed File System. As you can see inside Hue, this is our HDFS, and our data today which we are going to process is located in this data folder inside MR folder and word count, and this is the folder, this is the data which we are going to churn. It is essentially concatenated ebooks of Sherlock Holmes. Okay, these are the ebooks concatenated together into a single file, and it's not big in size, it's only 6.4 MB. All right, all right. So this is our HDFS, which means this file could be hundreds of gigabytes in size. Okay. Now, this is the file which, for the example case, we are taking a smaller one, but you can definitely churn gigabytes of data on this cluster. All right. Now let's open the console. If you open the console, enter the login password, and you will get into this. Okay, you will land here after clicking on console and providing login and password. After clicking on web console and providing login and password, this is where you will end up. Now, this is a full command line. You are in full control. You can do anything you want by, and we are going to run Spark from here. So I've just started Spark. This is connected to HDFS. It's running on the cluster. That means it's going to do things on the cluster. Whatever we do, it's going to run it on multiple machines. All right. Now this is the console. This is a console. We also call it read, evaluate, and process loop. Read, evaluate, and REPL, meaning we can type a command here and it get executed. Right now I've just written the first program. This is a Python console with Spark connectivity. This Python console is connected to the Spark, and what we get out of this is one object, extra object called SC. SC is your gateway to Spark. When you run Python normally, you will get exactly similar console with this kind of a command line with 3 arrows, and you can type anything in Python, but you will not get SC. PySpark is basically a wrapper over Python where you get one extra object, and this extra object is nothing but your gateway to Spark. This object will let you talk to Spark, and PySpark is that. So you can run any Python code on this command, as well as you can talk to Spark. Okay, so here I can write any function, say I'm writing my simple function called sum, or let me just call it sum, x comma y, and then I'm saying return x plus y, Okay, so this is the first function I have written in Python. Now I can test it whether it's working or not working. You can see I've called the function which I've defined here, and it has worked well for me. Okay, so this is a bit about Python because it's a Python console connected to Spark, and that's what is PySpark. PySpark is a Python console connected to Spark. What is Python console? Unlike your Java, Python provides you a way of evaluating every expression you type immediately. So any expression I type get evaluated immediately. Now you can see that x is 4. I can say x equals to x plus 1, and now x is 5. So I can evaluate whatever I type immediately. All right? That's about the console. All right. So we were successfully able to run our PySpark, and we were able to type something here. Okay. So now let's move to one more concept. A question from Senthil is, do we have a PySpark GUI? Not really. PySpark is this way. If you want to monitor what's going on, you can open this URL and check in the browser what is going on. Instead, I'll just say e dot. Okay, so instead of typing this local IP address, because it displays a local IP address here when you start, so this is your local IP address. Instead of this local IP address, use e.cloudxlab. That will show you the status of Spark running currently. Okay, it shows how much memory is running for your Spark shell, and what the storage you are consuming, and the environment variables. These are the environment variables for your Spark that's running. So everybody would have, when you launch your Spark, you might get different port here, different URL here. Okay, so you can take a thread dump, you can do a lot of things from here in order to evaluate and debug your jobs. Okay, right now since we have not run any job, it's showing that there's nothing much that has been loaded. Ravidas's question is, this Python code does not run in distributed way, right? It's just Python. Perfect. That's exactly what it is. So this Python code does not run in distributed because it's running locally. When I say 2 plus 3, it's running here just like normal Python. It's not going to Spark and talking. Unless we talk through SC, we are not talking to Spark. Okay, the entry point, the gateway is Spark, SC. We'll show you SC or SQL context. SQL context lets you talk to Hive or any other SQL connector. Here SC will be the one which will let you talk to Spark core and Spark libraries. A question from Senthil is, can I run it like a Java file? Yeah, by storing my code block? Yes, you can do that. And it's pretty simple. You can do a Spark submit. You write your code in one Python file, all of the code in one file, and then do Spark submit. And it will run your code in a batch-wise fashion. Okay? Because this interface, what you're seeing right now, is basically evaluating whatever you're doing right away. This is not great way of doing it in production. This is good way of doing it in development mode because you're trying to build, test as we build. But in production, you would like to get it executed immediately in a full way. There you use a command called Spark submit. Okay? Spark submit lets you submit Python code, Java code, or Scala code. A question from Rama. After we install Python, how can we actually connect Spark to Python? So when you run PySpark, it will automatically connect to Python. It will find out using the environment variables. Next question is, how can I access e.cloudxlab? So for that, you might have to get the login password, and you will have to enroll for the class. Okay, enroll for the CloudxLab. Is that your question? Did I answer your question, Rachit? Okay, Rachit's question is how to submit a Python file from my local to CloudxLab. Good question again. So first you copy the file using WinSCP to e.cloudxlab, for example. Okay, and then use Spark submit. Or the Spark submit provides a way to remotely submit a job, but the cluster may not allow for security reasons. Abhilas's question is how to run Spark with Java. So you'll have to use something called Spark submit. Again, Spark submit is same for Java as well as Python. So you can submit your full jar bundle using the Spark submit. Okay. So today we are going to talk about Spark. We are going to talk about Python with Spark, because going through the Java will again take a lot of time, but the concepts will remain same, because I did not want to get lost in the details of a programming language. That's why we have consciously chosen Python. Yeah, Krishna, your question regarding audio file is a little advanced. Can we take it maybe offline over the email? It's a little advanced to explain here. All right. What's the difference between Spark context and SQL context? Spark context is your gateway to Spark core, as Spark core. Where is my slides? Yeah. So Spark, PySpark is your, SC is your gateway to Spark core, while your SQL context is your gateway to this. All right. So that's a question from Ravidas. All right. All right. So Rachit, if you just ping me regarding Java separately over the email, I can send you like 2 minutes of my other video where we have done the Java way. Okay. So because Rachit wants a little bit introduction to Java, and I don't think the time would permit here. A question is, which is more efficient, writing code in Java, Scala, and R? Any performance issues? Honestly, Python program will be slightly slower, but in distributed computing, it doesn't make much of a difference to save 1 millisecond over running a program. Because at the end of the day, when you distribute the work, the performance jumps by many, many times. All right, now going back. All right. Okay, so yeah. So Venkat says, please start the session. Yep, we will take now. A question from Ravidas. Is the port number 4041 same to no Spark job? So this port number keeps on regenerating. If there are 4040 is busy, then it will be 4041 and 4042, 4043 and so on. Alright, a question from Senthil. Uh, what is the difference between Hue and Cloud Data Manager? Cloud Data Manager lets you install Hadoop, while Hue lets you interact with various components of Hadoop. Okay, sure, Rohit. We will note down the question from different people. All right. Now, okay, so, all right. Krishna, I'll answer your question at the end. Okay, not worry. Let's focus on the task at hand. So any kind of processing is possible for your knowledge, and the answer to your question is yes, as long as there is a library available for audio processing. Question from him was whether we can do certain audio processing, yes or no. The answer is yes. Okay, and you will see how it is possible. All right. So the first concept before I jump into the core directly is, or should we? I think we should take a 5 minutes break, and then we will take it further. All right, let's take a 5 minutes break, and we'll be back by 9:10 p.m. IST. All right, everyone. All right, everyone. I'm back. Should we start now? Should we start now, everyone? Great. All right, so everybody is back. Let's start now. There are two more questions before we further go into the details of RDD. First question is, do we have Cloud Data Manager as well, manager in CloudxLab? No. We have set up, we can only set up Hadoop using one manager, and therefore we have used Ambari for this one, and we have not used Cloud Data Manager, so answer is no. Now question from Gomati is, can Spark handle semi-structured input text for batch or streaming? And yes, Spark can handle both semi-structured data. Okay, even for streaming as well as normal, it can handle the semi-structured one. Instead of explaining, I'll try to show it during today's discussion. All right. Great, great. That was a great, probably, this session is quite much popular across. So, as of now, there are many more questions, and I'll try to answer those as we go forward. All right? Most of those questions will be automatically answered when I talk further. Great. So the core concept in Spark is RDD, a resilience distributed data set. This is a core concept around which the whole Spark core built. Okay? Around the Spark core is basically the biggest component the Spark core is built of is RDD. Resilient distributed data set. Basically, an RDD is a data set, or you can say it's a collection of elements partitioned across the cluster, meaning some elements on one node, some on another, and so on. So RDD is a representation of data in a distributed fashion. So, for example, let's say a file is being loaded from HDFS and it has got 4 parts. The same file, when it gets referenced from RDD, that reference, the RDD will be holding 4 different references on 4 different machines. Okay, so a reference on the first node will be pointing to the data which is here, second here, third here, and fourth here. In case we cache the data, that's an advanced concept in Spark called caching the data. In that case, it will be the real data here. So RDD could be the real data or pointer to the data, but more importantly, RDD is a distributed representation of data. You can always think of an RDD as like a big array, and internally this array knows which part is on which machine, or internally the array is basically a pointer to the data, and this data is across the cluster. Okay, so you can always think of an RDD as a big array. Some of elements are in one node, some of the elements are in another. Okay, and this RDD, which is by default a kind of pointers, and it's like just referencing which data is where. This RDD can be loaded from anywhere. As I gave you in the diagram in earlier, the data can be loaded in RDD from various sources, and this RDD can be persisted into the memory, meaning cached into the memory, so that we don't have to again and again fetch the data from various sources. RDD can also auto-recover from failure. How does it auto-recover from failure? It again load from the source. If the data gets lost, if the node gets lost, the same part gets moved to another machine. And that's how the RDD rebounds or resilient. Resilient means it kind of resilient means it's fault tolerant. It recovers from errors. Now, the question which you might ask all the time is, what is it that RDD can keep? Is it only the string, or only the binary, or anything, or only the So what data type? It can hold anything. Just like in a programming language, there is an array. The way you have in programming language an array. And what is an array? Array is a list of pointers to objects. In the same way, an RDD is a list of pointers to various objects located on many machines. And this RDD can contain integers, anything that an array contains, whether binary or any format. Okay. Now, there are basically two representations of array: array of normal elements or array of key value pairs. If you have array of key value pairs that behaves, that's good for many key value operations like sorting, like various group by functions. So the key, so if array is built of key value pairs, we can interact with it like a hash table. So these are two things. Now, what is it that we can do on this array called RDD? This array of elements called RDD. What is it that we can do? We are not allowed to, do all kinds of operations, but you can always iterate over the array. But since this array could contain billions of elements, an RDD, when we talk about big data, an RDD could contain 100 billion elements. Some elements, few billion on one, few million on another, and so on. And iterating over these 100 billion elements is not a great idea, because if you iterate, go from one end to another, it's going to consume a lot of time. Instead, the way Spark has come up with the whole strategy is two kind of operations. Two kind of operations you can do over RDD. One is called transformation, and other is called action. Transformation converts one array into another, meaning one RDD gets converted into another RDD via transformation, while if you want to bring data back, or if you want to shuffle data, you want to make some action, then for that there is another group of functions called actions. Okay, there are two genre of functions, two kinds of functions that you can do over RDD. One is called transformation and other is called action. All right, we will see these now. Now, RDD cannot be modified. Instead, when we do some operation on RDD, another RDD gets generated. Okay, when we do certain operation on RDD, another RDD gets generated. So RDD is read-only. Okay. A question from Senthil is, what if data gets updated? Does RDD auto-cache it? No. But it can recompute it when you demand it. When you call an action, it will do the recomputation. Kritika's question is, if RDD is auto-recover, then we need to maintain some name node type of thing to maintain the connection between RDD and actual file where it will load. Yes, that's something job of Spark Master. Okay, that's a job of Spark Master, and that is being taken care by Spark. Now question is, what if that particular node, the same thing gets loaded somewhere else? Kritika is saying how it will know that RDD is corrupted. So in case one of the node is down, it can't get the heartbeat back, and therefore that particular portion which was dedicated to that machine will be reloaded somewhere else. Okay, a question from Kritika. Plus, if it's a key value, if an RDD is a key value, is it index based on key or a value based on key? So key will be used for running the functions like reduce by key. We will see it when we see the set by operation. An RDD provides various kinds of operations, and some of those operations honor the key value. A question from Parvela is, I'm not clear with RDD being read-only. Can you please give a short description? Okay. So in most of the programming language, string is a read-only object. String is a read-only object, right? Like we have, if we say new string equals to my string plus 1. That means I'm trying to concatenate 1 to this old string, right? So we are trying to do some operation on this string to create new, but we are not modifying this string. In the similar way, we will have some operation called my operation on an RDD. Okay, we can say something like this, and it will generate another RDD. We will talk about what kind of operations are allowed in the next slide. A question from Gomati is, what's the advantage of the feature of RDD? So when we do certain operation, the Spark will take the notes of all these operations, and then when we say an action, all the transformation which we are doing, when we say an action, then it will do the recomputation and figure out which operations need to be done. And this kind of planning is better done with a read-only RDD. So the objective of a read-only RDD is to make it possible to do the planning over RDD. A question from Kritika further is, what if we try to update RDD? Okay, so the RDD doesn't have a function which let you update it, which let you changes it. RDD as an object does not expose any function which would let you update it. The way string as an object does not let you make a modification to a string. In a similar way, if you try to update it, let's say there is an RDD object, you said load from, okay, I think we are jumping ahead a bit. Alright, let's take a look. I think Kritika, once we take a look, you will get more clarity on what do we mean by RDD. Instead of talking it, let's look at it. Alright, let's create our first RDD. Okay, so let's go to the console Okay, so what do you see here? As this is a Python array. Okay, let's make it a separate array. My array, my Python array, I'm just giving this my variable name, and I'm creating this Python, what do you say, Python object. Okay, and then first we created like a normal array. We created like a normal array. Now my py array is this. This one is nice array. It lets us do kind of modifications as well. So you can see my py array. Good. We were able to modify 34, right? But if you now this is nice array from Python. It's right now it's into Python variable. It's loaded into the memory on this computer into the Python interpreter. Now next thing is let's convert this nice Python array into an RDD. And how do you do that? We tell Spark that could you parallelize my py array. We say sc.parallelize and py array. You can see that? Good. Now if I say my py array, we say, it says that it's an object of type parallel collection RDD. Okay? It's an object of Python. Now, if you want to see what kind of functions are allowed onto this are these functions. Okay? You can go into the details, but that will be too overwhelming at this point of time. Okay? So, we'll go into only these few functions. Okay? A question from Parvela, is there a way to retain array values once we exit Spark and launch Spark again? The only way is you save it somewhere, or you can say persist it into the disk. Can we use Spark context SC with R? Because I could see material is yes. Because the way R has been implemented on Spark is by the use of data frames. Data frames in an alternative representation of RDD in R. Okay, and those data frames are part of SQL context. So therefore, you cannot use Spark context SC in R directly. You'll have to use SQL context. Okay, but there would be a way to reach to SC. All right. Now moving ahead, so that way we were able to successfully convert a data like my array into an RDD. Now let's take a peek into it. Into what does this RDD contains. So we use a command called myArray.take, and we say give me 10 elements. When we say take on this RDD, it brings data back to you. It brings data back to you from the cluster. When we say parallelize, it takes your local data onto the cluster, and when we say take, it brings the data back to you. Okay? So this is an action which did our job and brought our data back, while we will see more transformations very soon. Okay? A question from Randhir Rahi. Welcome, Randhir. Randhir is one of the students, like a few more students in my class. And in sc.parallelize, my py array can be anything integer etc. Yes. It could be anything you want to try. I think you would have access to CloudxLab. You can try it right away. Okay? To start this console, you will have to type PySpark, P-Y-S-P-A-R-K. Okay? So those who want a copy of the code, just raise the hand. I'll just copy paste the code, whatever I'm doing, so that, anyway, I'll just copy paste to everyone. Okay? Just in case you're trying to do something. Alright, that was the easiest way and quickest way to create an RDD from an in-memory object. Now let's move on to the next level. Okay? Now let's load this file which was there. You remember this location? We talked when we went into Hue, we could see this file, right? Where if you see here, it's data mr word count and inside input. Actually, there is one more copy of this file inside input. You can see that. Now, this is the file which we are going to load now. And you will be amazed to know that since my Spark is running on top of Yarn, the file location without any protocol means the file is on HDFS. This file, it will automatically find because it's running on top of HDFS. Okay. Now let me try to load this file from HDFS into an RDD called lines. Okay. I'm giving this RDD a name called lines. Okay. Now let me check. Nice. It says it's a map partition RDD. It has automatically detected that I'm trying to load a data from HDFS, and it has created different object type this time. Earlier it was basically from the memory. Now this lines, if we say lines.take 10, you can see that it has brought first 10 lines. These are the first 10 lines in the form of an array. It is in the form of an array. Okay. The U which you see here, it means Unicode, means data is formatted in Unicode, and the one element from another is separated by comma. The second one is an empty line. Okay. Let's have a look at this file. So you can see first line is there. Okay, let me again look at it. So first line is there, this is the first line, then there is second line, then there is some third line, okay, and there is some empty line afterwards. And what exactly is here? You can see there is one empty line and so on. Okay, sounds good to you? We were able to successfully load a file from HDFS. And this whole file which is lying in HDFS can now be processed as part of. A question from Hemant is, what's the max memory size of RDD? RDD does not run inside memory all the time. It's basically a representation pointed to the data. It's not the actual data. We can, yeah. So there is no worry. If there more data is there, it will automatically resize. Yeah. A question is from Rahul is, can you explain the log generated after you created RDD? Let me show you that. Okay. So you can see here the way I'll just say. So when I say sc.text file, it did something. It says that it's trying to make the memory free, trying to broadcast and talk to the cluster. Okay, it's trying to create the memory pieces, point to the various locations. Okay, so that's what it's trying to do. It's trying to talk to HDFS at this point of time and trying to link the RDD with the actual file. A question from Abhilash Kohli. Can copy dataset from local to RDD without having in HDFS? Yes. You can use parallelize. Okay? Parallelize is exactly for that. The previous command. Make sense to you, Ravidas? So the first command which I did basically loaded my local data. The data which was with me. And yeah. Alright, so we were able to successfully load data from HDFS as well as my local data into an RDD. Alright, so that was our first step. Now, what can I do on top of an RDD? Okay, what can I do on top of an RDD? Okay, I'll just delete this section. Alright, so was I able to answer your question, Ravidas, regarding, there was one more question, sorry for that. Okay, the question looks interesting. Alright, does the file get splitted across data node while loading the file itself or while the job is running? So the file basically in the beginning, it just locates which data nodes are there and makes note of those. That's it when we say load. A question from Rajit. If parallelize is used for a local data file, not HDFS, then where RDD will point to? Yes, very good question, right, Rajit. In the case of parallelize, in those cases, it tries to use either the memory or the local cache on different nodes. Okay, local cache on different node. All right, let's try to take a step further. Now, we did. This is what we did. This is what we did, and we loaded the data, and then once we have loaded data from HDFS into RDD, now one of the things which you could do is run a transformation. Transformation translate one RDD into another RDD. It does not bring the data back. Or as well as one more thing to note is when we execute a transformation, actually nothing happens then and there. It doesn't happen, a transformation does not get executed immediately. Instead, a chain of transformations get executed the moment you call an action. So transformation is telling the orders to the waiter standing on your table, and action is telling the waiter that go and get it done now. Okay, so when we say do this, do this, do this, it doesn't start immediately doing the transformations unless you call an action. An action is what makes a transformation get executed. Now, why is this kind of weird behavior? Why does Spark wait for action to be executed for various transformations to be executed? Why does it wait for an action? Why? Because that gives Spark ability to optimize, right? Imagine that you went to a hotel and every time you said, okay, I want salad, and then waiter runs away to get the salad instead of taking your other orders. In the same way, transformation is like you're placing the orders to the Spark, and then when you say action, and then it does all of the transformations. Okay, so transformation generates another RDD. Okay, a transformation generates another RDD. Transformation does not get executed immediately. There's a lazy behavior of transformation. It waits for the Spark waits for an action to happen. Only then all the transformation before an action will be executed. Okay, so a driver is something very important concept here. Driver is somebody like right now we are the driver. This console from where we are giving the order is the driver. We are on the driver's seat. We are giving the orders to Spark. At a later point of time, when you run Spark Submit, a particular node becomes the driver, and that node will be telling various machines what to do. And that's the idea about drivers. So from the driver, we loaded the data into RDD, and then driver has asked again to create another new RDD by the way of transformations. Okay, let me answer your questions. Yes, thank you, Hemant, for that analogy. Okay, so Hemant is saying that it's more like pig, where till the dump PTC are executed, okay, it waits. The whole idea of this kind of lazy behavior comes from a language called Sogel, which was there at somewhere in Yahoo or somewhere. Okay, so yes, that's exactly the behavior is. All right, a question from Rachit. Will transformation create a new RDD, or it will wait for action to create a new RDD? It will wait. Okay. Now, the next question from Gopal is, if the RDD data storing in cache memory, how is it possible? The quick answer is it doesn't. Most of the data which is held in the memory will actually happen after you say an action. Till then, there is nothing happening, honestly. It's an RDD, moreover, is moreover a pointer to the data, not the actual data. It is said that Spark utilizes RAM, but that doesn't mean that it is going to overflow the RAM. It will take care of the memory very well. In case something is going beyond RAM, it's going to keep it in the disk. All right? You will see that. Right now, this lines, when we say here, lines, the one which we have loaded, right? This lines equals to sc.text file. Okay? Now, the previous object has been overwritten just now because we have executed the same command again. So now, lines equals this. That doesn't mean that so full data is inside lines. Lines is just an object which has all the pointer references saying partition 1 has come from block 1 of from the data node 1 and so on, and partition 2 has come from such and such data node, partition 3 has come from such and such. So it has pointers to the location. It has links to the actual location of the data. All right? Okay, a good question from Rachit. What's the max limit of parallelize? The interesting part of parallelize is you can execute parallelize only if you have data in memory, which means it has to be practical data to be loaded into the memory. That means it is not that big difficult to load all of this data which is loaded in one machine's memory into 10 machines memory. Okay, so that's the idea. Before you reach the limit of the memory on any of the machines, you will first reach the memory on your local machine, and this is governed by Yarn's memory. This is governed by Yarn because it's running on Yarn, and this will be governed by how much Yarn can allow. A question from Gopal. You mean the data still remain in SCF, we are just accessing the line object? Yes. Okay. Now, since we have loaded the data, now let's talk about few transformations. Now, the most important transformation is map. Okay. So this map transformation is a very interesting one. This is a classic map reduce which comes from most of the procedural languages, functional languages, I would rather say. So what it does is it runs this function, whatever. So the interesting part about map function, which an RDD allows a function like map to be run on it. The most interesting part is the argument it takes is a pointer to the function. It takes a function as the argument such that it can run the function as it wants. It will run this function against every element of RDD, and whatever is generated out of it will create a new RDD from that. Okay, so and then there is another transformation called filter. If you have many elements loaded into an RDD and you want to keep only few, you want to remove certain elements, you can say filter, and then you can pass a function to this, and this function will decide which, this function is your code, this is your code which you are giving to the filter so that Spark can remove the element for which your function returns false. So every element of an RDD is going to be tested. Every element of an RDD is going to be tested against your function, and for whatever elements your function says yes or true, those elements will be put in the output. Then there is flat map. So what does flat map do? Let's say there is an RDD which contains few elements and you want to generate more elements. In the first function called map, the total number of elements in the output are equal to the total number of elements, meaning one element of one RDD gets translated into one element in the output. So a map converts an RDD into another, but both RDDs, input and output, will have equal number of elements. While flat map converts one element into many, so the RDD generated by flat map will contain far more elements. You will see in the example which I'm going to show right now. Gomati's question is, when you create a new RDD, this will point to each of the RDD in each node in distributed way? Yes. Okay. It's actually quite complex way internally, the way RDD takes care of the things. So question from Parvela is, can we define number of transformation? Instead, we can define number of partitions, as in how many elements are going to be on which node, and total RDD is going to be partitioned in what way. That we can define, and accordingly the distribution of work will happen. A question from Ramakrishna, is there a function in Spark which can use for anomaly detection in data set itself? So that generally you can go for Python or Spark library, Python or say any other languages library that can help you out. There are many statistic library you can use. Okay. Now we can go ahead with the next one. Now next phase is, let's try to, now we loaded our data into the memory such that every line in the input file was one element of our RDD. Now we want to convert each line into one word, meaning our new RDD should be one word per element of RDD. What do we need to do? We need to break down line into words. And what should we do? We should use flat map. Flat map converts one element of one RDD into many elements in another RDD. So what exactly are we doing? Let's try to define a function called toWords. So this is my function called toWords. Okay, and what does it do? It breaks down. Let me try to run it. It has broken down this string into an array. You can see that. So I passed a string as an argument to toWords, and it has broken down that into an array and return. So this toWords is a function of Python which converts a string. It's my function which I've just written is a function which breaks down a string into an array of words. Now What's next? Now let's try to execute flat map. Now you can see what am I going to do right now. Here you can see lines is an RDD which contains all which points to, or which is basically representing big.txt file, and every element in lines is a line from my file. Now when I say flat map, two words, this two words is going to get executed against every line of the file, or you can say every element of lines RDD, and whatever is the result will create another RDD called words. Okay, this words contains, now let's take a look. And how do you take a look? By calling a function on any RDD, or calling a function called take on any RDD. I'm just trying to take, you can see now this new RDD is an array of words. This new RDD, you can see, is an array of words. It is the project, Gutenberg, and so on. So the full file has been broken down into, so earlier RDD is now broken down into a new RDD which contains array of words. This new RDD is made up of array of words, Now that was the result of the flat map. So everybody is with me. Ravidas's question is flat map same as flatten in pig? Not really. Flatten is ungrouping, but flat map is equivalent of map reduces, Hadoop's map reduces map. The way map could produce many key value pairs for an input line, similarly this flat map can convert one element from one element into many elements of an RDD. A question from Parvela. Can we specify a delimiter while we split? Yes, you can do that. You take a look at loading the file, and there you can provide, while the way we loaded a file was very straightforward, we said load. There are many loading functions which you can use in order before loading the data. Or you can load the full file. There are many more loading functions. It will take maybe like a 3-hour session. Okay. So in one of my no big data sessions, I have given the full details, like a 3-hour session, on what all ways you can load, how you can delimit it, how you can load JSON data, how you can load XML data, how you can load binary data, and how you can load the complex data set in RDD. Okay, there are many ways to load the data. Okay, so a question from Rachit is difference between map and flat map. So flat map is, map only can convert one value into another, nothing else. One value cannot be converted into many values using map, but using flat map we can convert one value into many. That's the difference between map and flat map here. Okay, now let's take a look at how we can use. So now we have data but not clean. You can see here the data is not lowercase. You can say give me 30 records. Okay, you can see the data contains like this kind of like brackets and all. Okay, so we want to remove, or the hash, the numbers, we want to remove these kind of special characters and convert it into lowercase. In that case we can use map. We can use map in the sense like, let's define a function, let's define a new function called clean. And the way you do is, first you import a library called regular expression. Now this will also help you understanding this. We are using Python library inside Spark, and that's perfectly valid. Okay, that's perfectly valid, and that also clears few things, that in a Spark you can do many wonderful things using the native library of a programming language. Okay, so now we have we have imported the regular expressions. Now what is it that we are trying to do? We have written this nice function called clean and generate key value. What it does is it takes a word as argument, converts it into a lowercase. You can see that we are converting it into a lowercase, and then using a regular expression, we are removing all non-alphanumeric characters from the word. We are deleting non-alphanumeric characters from the string and returning key value. Okay, this representation of round brackets in Python means it's a key value pair. Okay, internally Python defines something called a tuple, which is not there in other languages, which means it's a key value. Now let's test whether this works or not. Let me just put some dirty data. Let me say Sandeep dash 1 Giri. Okay, let me see, or you can say we can put some exclamations, put at, and so on. So does it clean the data? It did. It removed all non-alphanumeric characters and made a key value pairs. The value is just 1 for now. You will understand why I'm putting 1, so that while grouping and counting I can just sum it up. Alright? Alright, so a question from Hemant. I get a feeling this Spark is going to take much less number of script even if compared big for this. Yes. Actually, I would say credit goes to Python for this. And yes, that's the reason I've used Python. Alright, now let's try. Right now we just tested that, oh, our function called cleankv is working fine. Now we can, so what does cleankv do? It takes a word, returns a tuple. Right? Now we can use, we can say words, we can execute, we can say clean words kv. Clean words kv will be the new RDD, and this is the input RDD, and we are going to run clean kv as a map. Clean kv is a function name that's going to run against every element of words and create a new RDD called clean kv. Right now it will just make a note of it. Unless we say do something, it won't execute map or flat map. Okay, and how to ask it to do something? By taking say 20 elements or say 40 elements out of my data. Now you can see every word is very much cleaned. You can see everything is like I mean, everything is lowercase, removed all the, I mean, special characters. Now is the time that we go ahead and talk about actions. Okay. Now, yes, take is an action. That's right, Rajit, you guessed it right. Take is the action which we have been using. So action is something which brings data back to you, or which takes data, which actually makes something execute. These are the functions, these are the type of functions which do something, which get things done. There are many actions such as reduce, count, collect, and take. Take, which we have been using for quite some time, basically brings a few elements from RDD to you. Collect gets all the records from RDD back to you. But remember, collect is going to overflow your memory because it's going to bring data to your memory. And count will just count the records, while reduce is the function which is going to group the data, sort the data, and then run the function, aggregate function, which you pass as argument. So to run the reduce, you pass a function which takes 2 arguments but return 1. This function which you are going to pass to the reduce is a very special function. It's called an aggregate function. It takes 2 arguments and returns 1. And since reduce is, okay, let me take a step back again. To reduce many records into 1, let's say there is an RDD of numbers and you want to sum it up all into 1, you can use reduce function. let's say you want to concatenate the whole string spread across the RDD. You can say reduce and pass a function which will concatenate one with string with another, and so on. Reduce will bring the data to you by applying this. Reduce will bring the data to you by applying aggregation function again and again on every two elements of this data set. So it will keep on concatenating each two elements until there is a single element. Again and again it will apply the function, it will apply aggregate function passed to it in the argument unless there is one element left. Okay? So for example, the sum function which we had written earlier, you remember our sum function, which was basically doing the summation of anything which passed to it. And you remember our first data set which we loaded into the memory. And what was that data set from the parallelize? And anybody remembers that? It was my array. My array was basically, you can see, this is the RDD. Now, if I want to sum up all the elements of this RDD, I will say reduce and pass my sum function, and it has returned me 88. And the way it works is, it works wonderfully. This reduce function, which you see here, this reduce function divides the work of aggregation amongst the whole computers. Some computers are aggregating one partition, some computers are aggregating some part of the RDD, other computers are aggregating rest of the things. So reduce is very powerful in the sense that it distributes aggregation. Now there is one more aggregation called reduce by key, and right now we are going to use that aggregate function. It's called reduce by key. It essentially groups the data by key, and then by combining multiple keys together, it will call the function which you are passing as argument as the aggregation. So word count, you can see, will give you the real word count. Okay? Now let me just take this, what did I do? Words count. Okay? Yes. Now when we say give me 100 records, it starts functioning, and now you can see that it has given me 100 results only. Now if I want to save this data, I can simply save this data into my SDFS directly. Okay? By saying save my RDD into this directory. Okay? Now let's see, has it been done or not done, and what happened. Okay? Let me refresh my home folder. I click on home. All right. You can see it has created a new directory and saved my data here. This is my results. These are the results. You can see that it has done the word count for me. Okay, you can see that it has done the word count for us. Okay, so what does reduce count do? Okay, a quick question. Reduce count do, in a key value RDD, an RDD where each element is a key and value. Okay, key and value. It first groups the data by key, and then for each key it reduces values by applying a function f. So okay, so when you call reduce by key and pass a function f to it, it will first take the RDD on whatever we are doing reduce by key, find, and then groups the data based on the keys. And remember, we generated keys, key values in using clean function, and then After it has grouped the data, it will bring all the values for each key together, and on those values it will apply this function again and again to get a single value. Okay, so it has applied some function again and again on all the values of a key, and that's how it has computed the total occurrences of a key. Alright, so right now we have done the word count using reduce by key. Okay, so that was, I know this was a little too quick. I think this diagram will help you understand what exactly we did in the word count. Okay, so this is what we did in the word count. Let's take an example called, let's say this was our input string. After taking a shot with his bow, the archer took a bow. Okay, now when we said flat map, this data got converted into an RDD which is made up of these partitions. Okay, it converted the full line into words. You can see that some of these elements are on one computer, some of these elements are going to be another computer, and so on. Now, once we have this distribution across the cluster, okay, once we have this distribution across the cluster, then we run another command called map. And also note that flat map converted one element into many elements. You can see that. Now, but map converted one element into one element into one. It basically cleaned the data. It removed comma from dot from here and comma from here. Okay? Comma from here and dot from here. It basically cleaned it. It made it lowercase and so on. Okay, then afterwards, you can see that the shuffling happened when we say reduce by key. When we say reduce by key, the data got ordered by the key. You can see every element is made up of key values. This data got ordered by key. You can see that the A came first, and then after the arc, and so on. And once the data got ordered, it got grouped as well. And for each group, your function called reduce, sum, got executed everywhere. A function called got executed everywhere. This is what happened. Sum was executed on 1 and 1 and became 2. Sum was executed 1 plus 1. It became 2, and so on. Had there been more, the other summation will come up at this point and more results will happen. And then the data got saved here. A question from Gomati is, grouping of data in RDD occurs in each node parallelly? Yes. And if required, if data transfer is required, it would do the transfer for you. Okay? So the grouping, sorting, everything happens parallelly on all the nodes. Ravidas is saying we have part 0, 1, 2, 3 in 3 different nodes. Then when you query the tables using Hive, which data file gets populated? Can we query these separate files from Hive? Yes. You can load 3 files. You can load the full folder in Hive easily. Okay? Hive allows you to load multiple files. Okay? Yes. When you save to HDFS, only then the whole process starts. Alright? So that was a great set of questions, and that concludes my session. Okay? Feel free to reach out to us at cloudxlab.com, and if you have any questions, let us know, and please enroll for our CloudxLab. That's going to help you a lot in trying and testing things. Alright? Feel free to reach out to us. We enjoy answering questions. A question from Vasu is, how do we do text analytics in Spark? The word count which we have done is actually a part of text analytics. And now, once we have taken the text and counted it, is basically we are doing analyzing text. We could do many other things over this. Let's imagine that we are doing the character frequency analysis in order to find out whether a particular text is in English or Spanish or anything. Just based on frequency analysis of the text, we can do many things. And this can be done very easily by using these few lines of code. Thank you, Ravidas. I'll just keep on copy pasting your answers here. Thank you, Ravidas, for a great feedback. I'm really happy. Thank you, Sasikant, for a great for great feedback. And thank you, Hemant. Thank you, Sadanjan. And thank you, Rohit. I'm really happy that I was able to do something valuable. And thank you, Ramakrishna. And I'm happy that, okay. So a question from Ramakrishna is, how many nodes can be created, supported in a single cluster? Actually, the Hadoop has been tested on around 50,000 nodes, one more. And I'm not sure what is the upper limit. Thank you, Rachit. I'm happy that that you found the session great. And okay, so a question from Gomanti is reduce and reduce by key differences. Reduce by key works on key value pair RDD, while reduce works on normal RDD. And reduce basically reduces the whole array into a single value, while reduce by key reduces the elements into unique keys, and for each key all the values get aggregated together. Thank you, Sandil. Thank you, Senthil. I'm happy that you found session valuable. Thank you, Ajay. And thank you, Hardyal. I'm happy that you found the session very informative. And thank you, Dina. And I'm happy, Naveen, that you like it. And thank you, Dinesh. Thank you, Dinesh, for the feedback. I'm really happy you enjoyed it. And actually, the word enjoy is something which I am very happy about. A question from Ramakrishna is, how many clusters will be there usually in a data center? It actually varies. And it varies quite much. Okay. So as an example, for some people it's just 10 cluster, 15 cluster, 15 nodes. And as I was telling you, at D-Shaw, even in 2002, we had 10,000 nodes. In Mobi, we had nodes in thousands. And at Amazon, nodes were in more than 10,000s. Okay. Thank you, Rajesh. Okay. I'm not a programmer, though I just wanted to understand the session is great. All right, I'm really happy because I was not prepared for non-programming audience. All right, but I'm really happy. And Sarvesh, I'm really happy that it's going to be a good start for you. A question from Senthil, Java, Python for MapReduce, Java, Python for Spark, Skill for Hive. Yes, that's right, Senthil. So Java, Python, I'll say Scala, and MapReduce, you can actually use any programming language. All right, I'm happy, Piyush, that you liked it. Feel free to enroll for CloudxLab if you want to quickly start learning right away, and you want to refresh whatever we have discussed today right away. You can just go ahead with CloudxLab and then. Question is that are these combinations right? Yes, these combinations are kind of right. So HBase provides you API which is in C, Java, etc. Okay, I'll just correct what you said. And here you can do any binary via streaming. Okay, I'll remove Python because Python, if program can be executed on computer, it can be executed anywhere. Okay, a question from Ravidas. I'll just take a few more questions and then we'll call it a day. And a question from Ravidas, while working with Spark, how could we go with visualization plotting? The question is that you do not plot big data generally. You generally reduce it to a smaller value or some insight or sample the data and then plot. And then you can plot using your standard visualization tools. All right? Because if you try to plot big data, when we say big data, it means more than few GBs, and it doesn't make much sense. The human eye is not so sensitive about that information. So Rajit's question is, when is your next session? Stay tuned to our Twitter handle, and you will get to know soon. Okay. Okay. All right. Great. A question from Ramakrishna, can we use Scala function to anomaly detection? I'm not sure if Scala is having a library, statistic library for anomaly detection. You'll have to check the library, but you can actually call any Java library from Scala, so it should be possible using Scala very well. All right. Thank you, Gomanti, that you liked the session, and I look forward for similar audience. And yes, other topics are going to be related to Spark and Hadoop and more towards hands-on approach. Okay. All right. Senthil, could you drop me an email? I could answer it over the email better than now. All right. Thank you, Randhir. I'm happy that you found the session great. All right. Thank you, Gopal, and I'm really happy for. Okay. Thank you, Muthu. I'm really happy that you found it insightful. Thank you, Ramakrishna. I'm really happy with your feedback. I think I remember talking to you once. Okay, so Rajit, just stay tuned to our Twitter handle. The second session is going to be Spark streaming. Okay, Spark streaming, unless other people vote for something else. Okay, and yeah. A question from Muthu, is Spark also work same with SQL, same as Python or other language? Yes. Actually, with SQL is little different. I'll show you later. Okay. So with SQL is little different than the usual way. Okay. Okay. So Ramakrishna, feel free to call me up and call our number. So that should be good. The number on the website. Or if you call the number on the website, somebody will give you my personal number and then we can talk. Okay. So although most of the people know my personal number, but and Rajit is saying, do we have design patterns for solving in big data, maybe Spark like MapReduce? There are minor design patterns to solve, but yeah, but you have to think through in terms of transformation and actions. The okay, Twitter handle is okay. So our Twitter handle is CloudxLab. Yeah. Okay, that's our Twitter handle. All right. Bye bye, Ravidas. Have a great day. All right. Okay, good. So yeah, you can just go through my introduction. I think my introduction is available on, because most of the trainings actually happen over No Big Data. So you can go over to No Big Data and there will be some previously recorded videos, as well as there is a YouTube channel of No Big Data as well. Yeah. So there you'll find those classic big data introduction and details. Okay, so Twitter handle is like @CloudxLab, you can say. Okay. A question from Gomati is, can we have a session for semi-structured file extraction? So the way we were just doing right now, data was semi-structured. So we can actually load data from CSV easily. Okay. And all right. So that actually, when I've covered in the Python Spark sessions, I have gone into those details, because getting into the loading file is actually quite exhaustive in Spark. And there are multiple ways to load data in Spark. Randhir is saying, can all MapReduce be converted into Spark? Theoretically, yes. Okay, Ajay's question is, can you share please the video and slide? Definitely. So by tomorrow you will get, by tomorrow. All right? Great. All right, thank you very much. I'm going to hang up now. Feel free to reach out to us at CloudxLab and follow us on CloudxLab Twitter handle. And maybe you can also like our Facebook page. All right, and more videos are going to be added onto our YouTube channels. We will keep on creating these kind of videos and put it in the YouTube channel publicly. And we're going to put more and more content into our video channels, YouTube channels. All right, have a great day. Stay tuned to CloudxLab, and bye-bye. All right.